Hey everybody, my name is Tokyo Roberts, and this is Study Hall for Galvanize DSI, for the prep space for Galvanize. I have not yet posted the stream link in the Slack for this, so forgive me if you're watching and I paused really quick to go ahead and share this. So if I'm silent for a little bit, don't worry. I'm going to be talking very soon, and I can start taking questions at that point. I had to iron out a small technical error with my tablet that I draw on. And even though I really love this thing, it's a XP Pen. I think it's XP Pen Artist. Relatively inexpensive when compared to, say, Cintiq or another other sort of higher end things. It has been a bit buggy at times, right? So fair warning. I think it's a great product, but I kind of want the consistency of a Cintiq sometimes, but that's really not what this stream is about. But that's me making excuses for being a little bit late. Okay, so you know what? Let me. We just started another round of premium prep, and so I'm just gonna post in our channel for premium prep on our Slack org. Essentially, saying that that study hall is going live, and I know I probably should have done this before I started streaming, but if you do have a question, a specific question, please feel free to post it in the thread for the study hall post today, and I'll get to it in just a second. So this is probably going to take me about 30 seconds just to let people know that that study hall is streaming. Okay. All right. So I still have up here a file that I was working on last time, and this is all stuff from kind of the later materials in our premium prep course. So I'm just going to go ahead and delete all of that. And I think where I'm going to start is just talking about some, for anybody who's new, I'd like to just point out, how you can run code. And, we started our class yesterday, and I didn't necessarily spend a lot of time on this. And I think that I could spend a little bit more time for people who are very new. So let me go ahead and get a browser up here, and we can start thinking about this. So let's look at Replit, right? And I think that's a place where many people start. I'm of mixed mind, mixed opinions about Replit. I think it's a decent product in terms of just being able to use it in code and do what you need to do, and you can import libraries, you can do whatever you need. I've actually used it for C++ at times. It's pretty flexible in a lot of ways, although it's weird for C++ if you're coming from that language. Just fair warning. But Python, it runs Python in your browser. That's kind of the whole story. Is this a perfect tool? No. And I'll give you a couple kind of reasons why you might want to move toward a local install, as I'm talking about this. One of the things that you're probably going to notice, and I'll just print a hello world here. One of the things that you're probably going to notice is that there is some time lag. Now, if I'm running this right now, that's not so bad, right? It just took it, rendered it. I believe what it's doing is bouncing off a server and, and rendering this output from that server. So I think there's a server call behind here. That said, there are times where you'll hit play and this will just hang. And you don't know if it's something with your code. It probably isn't something with your code. It's probably REPL taking its time. And in that sense, maybe there's a queue for server access and it's taking a longer time. I'm not sure. I guess this is something I could look into a little bit further. I'm sure that information is available somewhere. So one of the things that you find yourself needing to do is refresh this REPL. And the way that, if you find that it's hung up, the way that I would do that if you're on a Mac is Shift-Command-R. If you're on a PC, I believe it's, what is it? It's Shift-Control-R and that's like a hard refresh. And it'll, reload the DOM. It'll, fully pull in, what you're looking at in front of you again. And what you might find when you do that is some of what you had typed, some lines of code, or maybe a part of a line of code is missing because that wasn't actually saved to the REPL in that meantime. So you end up with a few like latency issues here and there, and I think that's something to be aware of. It might annoy you from time to time. It's not the end of the world, but it is something that might be a little annoying. There are alternatives to REPL, and I see your question, and I'll get to it in just a sec. There are some alternatives, and I'll just point a couple of these out. So, maybe if you if you really want to, there's you can look at this Brython demo. Oh, that's not where it is. Maybe it's here. Maybe it's here. Editor? Yeah, okay. So here we've got some Python. We've got a Python interpreter, and it just runs in the browser. So Replit is not the only place to go, and this is Brython using the ACE code editor. So this also exists. This is something that you can use to run your code, right? I could just replace this with a hello world, or really anything else, and I'm assuming it's going to do just fine, right? Hello world, it gives me time to completion. One thing I'm not sure about here, so how about we just do import numpy as np. Let's see if that will... Okay, module not found error numpy. So, if you use this Brython demo to run Python, you're not going to be able to import numpy or probably scipy or other things. Let's just check from math import factorial and see if that works. Okay, that likely works. So factorial 5. Yeah. Okay. So you can import from the standard package, but you can't import modules, which is fine for most of the basic things that you need to do in the prep for the DSI. Another thing you might consider is Python Fiddle, which there is a Chrome extension that runs a Python Fiddle. I haven't used that, but I'm assuming it's probably fine. Or there's, let's see, Python Fiddle, go to pythonfiddle.com, and it's not found. Okay, so that doesn't exist anymore. I have used that before. I wonder if... okay. Looks like a lot of these have been deprecated, so that's not amazing. Yeah, I guess what I'm getting at here is that there are a number of different things you can use before having a local environment. Here's another one that we suggest in the premium prep course, Google Colabs, and this will give you a Python cell that you can run code in right here. So if I do print hello world, I know I'm just doing the same thing over and over again, but this is going to work. It's going to give me a hello world. So I'm going to use this REPL, and I'm going to use this Google Colab. One nice thing about both of these is that you can share them. One really nice thing about this about REPL is that you can invite people to collaborate with you. You can generate a join link and copy this, and I'll just throw this in. If anybody wants to jump in and play around with this, I'll throw it in the thread. And if somebody joins this, you'd be able to see directly what's going on here. Okay, so let me get to this question finally after I've been kind of jumping around. You're stuck on list method 2, lesson 20. Well, you've got a link here, so I'll just click out to the link and take a look at it. List methods 2. Oh wow, there's a lot here, isn't there? Okay, so we're looking at challenge 20. Write a function called get largest number among mixed elements. Yep, that looks like what it is. You tried using this code, and I'm just going to copy your code, and I'm going to put it in this. I'll put it in here, and maybe I'll just resize this a little bit so we can get a good look at that. Okay, so you pass in an array. Okay, now what is this supposed to do? I'll copy the description, or what I'll do instead is I'll just screen capture this. All right, so this is what we're looking at. Write a function called get largest number among mixed elements. Given any list, it returns the largest number in the given list. The list might contain values of a type other than numbers. If the list is empty, it should return 0. If the list contains no numbers, it should return 0. Okay. So we need to check type. There's a function that we can use for checking to see if a value is numeric. Now, we want to be careful here in how we define numeric values, right? So if we're looking at the largest value or the largest number, we only care about numbers, and what we don't care about, I think specifically, is probably just strings, right? The question is, do we care about Booleans? And I think that's a good question. So now what I'm seeing here is, okay, you've got a list and you've got a comprehension here, and let's see, word for word an array if is instance of word is int. Are we going to assume everything is an int? You know what, let me I'm gonna write this I'm probably going to rewrite this to be more simple Python, but I'm just going to see what error you're getting when we run this. Three is not equal to 5. Okay. Oh. I think I see what's going on here. So before I rewrite this, you're trying to return the largest number, but in like sorted is going to sort from smallest to largest, right? So we want to modify sorted to reflect that. So so what we might want to do there is I believe it's reversed is true for sorted, or reverse. I believe that's what it is. I think it is reverse is true. So here's where we open sorted, and I think we just want to put here reverse reverse is true. Let's see if that. Well, let's just see what this gets us. If I print this array, let's do 1, 2, 3, 4, 5. We should expect 5 as a result. We get 4. Oh, because we're returning list sub 1, not list sub 0. Okay. Okay. So let me run this and see if that works. I believe that's what the issue was, unless I'm having a little bit of a brain malfunction. Yeah, yep, that is totally what's going on there. Yeah, you sorted it, but it needs to be reversed, essentially. And then the second thing is you want to return list sub 0, I believe, if I'm reading this correctly. So let me just throw that in and see if that works correctly. Yeah, okay, so that passes the tests. I'm going to rewrite this so in a form that might be more accessible to people who are watching. So we're trying to get the largest number amongst mixed elements, right? So this is completely legitimate code. This is good code. In fact, we could even make this a one-liner if we want to be particularly cruel. Right, we could do something like that, and that would still be fine. Oh, name list is not defined. Of course, it's not. Should be length of. Oh, no. You know what? It's better as 2 lines. Yeah. Sorry, I was thinking because since list is sort of like getting rid of all elements that are not, integers, because I think maybe it is safe here to assume integers, like we're assuming that there won't be floats. And anyway, if we break this down in a different way, get largest number amongst mixed elements, we're passing in this list, right, which we're calling it an array here, and that's because ARR, because lists are sort of array-like. In other languages, well, in JavaScript, we would probably call it an array, and arrays in JavaScript are very much like lists in Python. Yeah, the first thing we can see is, or that we can check, is if an item is numeric, right? I think that's a good place to start. So if we're trying to boil out, let's just call this numeric list, we can do a simple kind of accumulator collector pattern, and we can then look at each item in this list. So for each item in the list, if item dot is numeric, then we should, oh, I'm sorry. Is that gonna work? No, I think we want to do if, well, we can do this a couple ways. The way that I tend to teach early on is if the type of the item, we can do, I think we can just do not equal to string. This is one way that you could write it. You could also use the function that was used prior, which is instance, in the prior version of this code, that the example or what I was playing with just a second ago. But type is sometimes easier to understand, especially in the beginning. We teach both. I think we put more of a focus on isInstance, even though you do need to be a little bit careful with isInstance at times. But the way isInstance works is we're checking if the item, is, maybe I would do this, if not isInstance of the item being a string, right? So if this evaluates to true, if the item is a string, then I want to say it's not a string. And maybe I'll do that actually. If not isInstance of the item is string, then we can collect into the numeric list, right? We can say numeric list.append, we can append the item, and then we can return the sorted version of the numeric list, and we could just look at the last element in it, -1. So let's see if that works. See if I'm making an error there. And here's a moment where REPL is taking a long time to run, and it looks like somebody joined, so there's another person in here. I think REPL will tend to run more slowly when you have a shared session. It'll take longer to resolve. I think it's trying to synchronize with the other person who's in there prior to running. I think that's what's going on there. Okay, so I believe this is also going to work. This is a little bit easier to decipher than the I don't want to say decipher. The last instance of code is really good. It's got it's using comprehensions. It's smart. It's well put together. But I think for people who are newer to this might be easier to understand. The first thing we do is we check the type of each item using isInstance. Make sure it's not a string. If it's not a string, we collect it into its own list, and then we sort that list and look at the last item, which should be the largest item. So this is just a little bit clearer for some people. So let me just check to make sure that passes tests. There is a chance that there's an edge case I can think of where it might not pass. And looks like, oh, of course, okay. We need a condition down here. So if, numeric list, right, I need to, okay. If the list is empty, it should return 0. If the list contains no numbers, it should return 0. So if numeric list is greater than 0, yeah, let's do it like that, greater than 0, then we can return the sorted, the last item of the list. Otherwise, we're going to return 0. So let's see if that covers those cases that are specified first. Oh, still have an error. Oh, if length, sorry, that's my bad. Length of the numeric list, right? That needs to be greater than 0. We need at least one item in there, right? To be able to return the largest item. So that's, let me just check that one more time. And okay, so this snippet of code works. This is fine as well. So, there are a number of different ways you could write this function. And yeah, any one of those ways is legitimate. Yeah, one of the main things is like, well, we need to make sure that we're not collecting strings. One thing to point out, though, this is going to collect true, right? It's going to collect Booleans, so just be aware of that. That may not be what you want it to do. That may not be the behavior you want it to perform, but it will do that. Okay. You don't have a specific question, but can we go over simulating a binomial distribution? Yeah, totally. Let's do that. Let's do that over here. And Yeah, there are a couple ways that we can go about doing this. If we think about, if we think about binomial, and let's see, hopefully this drawing, this tablet is working. I was having some issues with it a minute ago, but if you are thinking about binomial, you're thinking about it in terms of being a series of Bernoulli trials. So what is a Bernoulli trial? A Bernoulli trial is either going to be a failure or a success, right? And we'll think about that as a success as being a 1, a failure as being a 0. And if we're thinking about 1 or 0, and we're thinking about a series of these where we have n trials, right? So a series of n tests of whether or not we get 0 or 1. We have n trials. Let's just start off with n. We want to consider what is the probability of getting 4 heads in 8 flips of a fair coin. One thing that may be intuitive and obvious offhand is that the most likely outcome is going to be 4 heads in 8 coin flips of a fair coin. And the way we get that is we take n and we just multiply it by p, which is just 8 times 0.5, which is 4, right? So that's something we can see offhand. Now, a way that, the way that we often will start with binomial is, how do we want to conceptualize this? Well, if we're thinking about this as zeros and ones, we can start off with thinking about it in terms of binary, where we're counting the number of ones in binary. So one thing that we can do if we're trying to simulate a binomial distribution that has a probability of 0.5 for every trial in the series of Bernoulli trials, we can start off by just saying, okay, well, what is the first potential outcomes, right? And if we're talking about 8 trials, I should have picked a smaller number, but that's okay. We can start here. So 1, 2, 3, 4, 5, 6, 7, 8, right? That's one possibility where we get all tails, right? And then we can get all tails until we get 1 heads. So that's another possibility. And here's another possibility. We can get 6 tails, a heads, and then a tails again. We can get 6 heads and then 6 tails and then 2 heads. I think I misspoke just a moment ago, but and if you know how to count in binary, what you might be noticing is that I am just counting in binary to create an exhaustive list of potential outcomes, right? And if we're thinking about k in terms of the outcomes, here's an instance where k is 0, right? Here's an instance where k is 1. Here's another instance where k is 1. Here's an instance where k is 2. Here's another instance where k is 1. Here's another instance where k is 2, where we have where k represents the number of successes, right? And something to maybe realize is that there is only one of these, only one sequence where we get, if we have a probability of 0.5, where we get 0 heads, right? There's only one sequence where we get 0 heads. And there's also only one sequence where we get all heads, where we get 8 heads. Okay, so this is a starting point, and if we're going to try to simulate a binomial distribution, there are 2 kind of different ways that we can do that, okay? One way is through what I call here a counting approach, right? Here we're counting, and we're just counting in binary. And after we count, we'll just look at a sampling approach, because I think these are two easy ways that we can do this. Now, the counting approach is going to be, it's not going to be the most elegant thing. I'll just, just fair warning. The way that I'm going to construct the counting approach, there's a slightly more elegant way to do this. If you're in the Premium Prep, or if you want to look at our Premium Prep materials, I have in our slides a way to do this somewhat more elegantly, but at the end of the day, you're kind of doing the same thing. I'm going to do this with nested for loops, and you know, it's not the prettiest thing, but it will work. So I'm going to count from 8 zeros all the way to 8 ones in binary using a kind of just procedural brute force Python approach. So here is our, I'll just call this binary. I'll make it an empty list, and I'll say for, make this a little bit bigger, make it a little easier to see. So for, kind of curious if I can change this to a darker theme. That's okay. I'm sure I can, but I don't need to. Okay, so I'll say for I in range 2, and what this is going to be is a 0 or a 1. I could also just make this a list, right? 0 or 1. So for I in range 0 and 1, and I'm just going to do this 8 times. So 2, 3, 4, 5, 6, 7, 8. And I need to give these all different letters: J, K, L, M, N, O, P. Okay. All right. And I can do binary dot append, and I'm just going to append I, J, K, L, M, N, O, P. And I'll put commas between all those, of course. So if I want to see what this looks like, I'll make this a little bit smaller again. So for, I don't know, for outcome in binary, we can print each outcome and take a look at that. And all we're doing here is counting in binary. So if I scroll all the way to the top, it's all zeros. If I scroll all the way to the bottom, it should be all ones. If it lets me do that, it does. And this is all the potential outcomes of successes and failures for a, let's say, flipping coins 8 times, right? So what I can also do here is print the count of the ones. So maybe I would just sum the outcome instead, right? And this is going to give us some idea of the distribution of this will give us a sense of the binomial distribution, right, in relation to the number of successes in 8 trials. Now, how can we make this a little bit more informative so that we're not just sitting here counting manually? Well, we can do that with a dictionary. I'll make a dictionary, and what I can do is get the sum of the outcome, and I can ask if the sum of the outcome is not already in the dictionary, then we can do you know what, let me just pull this out here. So I will get the sum like that, and I'll say if that sum is not already in the dictionary, I can say d sub sum. I'm just counting it at this point. I'm going to just initialize that to 0, and then I can do something very simple. I can just say, I can increment it by 1 if it's already in there. And then I can just say for, you know, for count, I shouldn't use count, for num, for key value, I'm sorry, in d.items, I can print that key in the value. So just something like that, and this will give us the distribution, the count distribution for the binomial distribution, right, with a probability of 0.5. So that's simulating, you know, effectively simulating a binomial distribution. If we want to see the probabilities, we can simply take this value here and divide it by the sum of d dot values, okay? And that gives us the probability of k outcomes in 8 trials. So the probability of getting 4 successes in 8 trials with a probability of 0.5 is this 0.2734 value right here, or number probability right here. The probability of getting 8 successes in 8 trials is, you know, less than 0.4%. So that's one way we can go about doing this, and you know, I think that's fine. We could make this somewhat well, yeah. There's a bit of a rabbit hole I could jump down, but I'm not going to do that. Instead, what I'm going to do is take a quick sampling approach. Give me 1 second, though. Okay. Thanks for being patient. Okay, so we can also take a sampling approach, all right? This is a counting approach, and notice that what we get out of here is not only do we get an exhaustive sense of the underlying phenomenon, of an underlying phenomenon that leads to these outcomes, we also get the exact probabilities in relation to a probability of 0.5 per trial. That's something that we can see pretty clearly. What we can also do is take a sampling approach, right? And our sampling approach is going to be somewhat different. I'm going to say from random, I'm going to import, oh my gosh, choice. Sorry. I should just be able to, I'm surprised I didn't, that I had a little brain fog on that. So from random import choice, what choice is going to do is allow us to choose either a 0 or 1, right? Like so. That's pretty straightforward. So what we can do is we can write a function around this that is going to get us a random list of binary of length n. This is going to allow us to look at things longer or shorter than 8 trials, okay? But what it's not going to do, something we're going to lose here, is the ability to get an exact probability. We're going to get an estimate for a probability. So how do we do this? I'm going to wrap this in a function. I'll call this get outcomes. I'll just call it outcomes. I'm from an era of Java when people wrote setters and getters with the word set or get, and I'm trying not to do that as often. Start with n. We'll set n to 8 by default. Why not? And I'm going to just make a little collector called list, and I'll say for whatever in range n. Thank you for the auto-suggest. List.append. We're going to append a choice either 0 or 1, and we can just return that list. So if I run this, if I just call this really quick, one nice thing about Jupyter Notebooks or Google Colab, Google Colab is essentially a Jupyter Notebook running on a Google platform, on the Colab platform. It's styled a little bit differently, but it's essentially the same thing. I don't have to put a print around this. And, oh, it returned a list. Okay, of course it did, because this is actually called LST. So here's a list of 8 random bits. If I call this over and over again, it's going to keep getting me different lists of bits. I can also look at the sum of this, right? The sum of those outcomes. And I had 2 successes in 8 trials. 4, 3, 5. And I can kind of get an intuition here about what the more expected outcome would be. Our expectation here should be 4, right? Our most common outcome should be 4. So what I can do, if I want to build a sense of the probabilities here, is instead of having this exhaustive counting approach, I can take a sampling approach, and I'll just write something called sample binary, and we'll do a certain number of samples. Let's do 1,000. And I can call out to outcomes 1,000 times. And I can say, let's make a dictionary. And I will say for whatever in range, num samples. And I can do something like, let's just get this outcome. I'm not giving these very good names, but I think when I can't think of a good name, I'll often use res for result. But I'll just use out here. I could just call this binary. Let me call it binary. That's more meaningful. And I'll say if the sum, in fact, why don't I instead call this k? And I'll just make it the sum of the bits that we're seeing. So if k is not in the dictionary already, then I can say d sub k and initialize this to 0 and increment it by 1. So the incrementation is going to happen regardless. So I can return this dictionary, and this should give us a count in terms of samples. So why don't we take a look at this? And I'll say for key value in that dot items, I can print the key and the value. Okay. So notice that these are out of order, right? 2, 5, 3, 4, 6, 7. Of course they're out of order. If I want to see this a little bit in a somewhat nicer way, I can go ahead and sort it like this. Okay, 231, 108, 224, 276. Notice we are still seeing 4 as the expectations, the most common outcome. Luckily, I think this is not the most likely thing to happen. Outcomes of 3 and 5 are symmetric. And if I run this again, of course, you know, it's not this time. You know, it'd be kind of interesting to see how often they would be the same, you know. And that would be a different distribution, right? That would actually be, we could approach that as another binomial distribution if we wanted to jump down that rabbit hole, whether or not 3 and 5 are symmetric. And we could estimate the probability of that. So if I want to see the probabilities here and not the counts, I'm going to say v divided by the sum of, oh, whoops. You know what? I'm going to have to do this to do this. I'll get this dictionary out, and I'll do the sum of d dot values. And now we should be seeing estimated probabilities as opposed to estimated counts. Okay. Oh, dict.items has no attribute values. What am I doing here? Ah, that's where the issue is. Sorted d.items. There we go. All right. So why don't we take a look at this alongside? So these are these are estimate. This is an estimate, right? This is an estimate compared to what are the actual values. Notice we didn't even receive an outcome of all ones at any point. Notice that we are approaching these values. These, you know, we're kind of loosely estimating this, the actual probabilities for each number of successes, but we're not getting it quite right, okay? If we wanted to get this, if we wanted to make this more robust, we could run the sampling process over and over again, right? We could build this dictionary, say, another 500 times, for instance, instead of just once, right? Because every time we build this is going to be different, but if we build this 500 times and then average the results, we are going to start approaching the what I'm going to call the theoretical probabilities, the probabilities of the actual theoretical binomial distribution as opposed to this random sampling process that we're seeing here. So these, I'll go ahead and paste this code in. You know, this is just two approaches that you might use. So we'll call this a counting approach for estimating the binomial distribution, or for, you know, simulating a binomial distribution. And here is a sampling approach. So both of those will be in the Slack. There are other ways to do this. There are ways that you can have a varied probability so that you're not always doing 0.5. And if you think about how to do that, well, you know what? Let me just throw that in there because I think it's easy enough to do. So let's import choice and random. And what random is going to do is get us a float value between 0 and 1. So this will make a slightly more robust simulator of the binomial distribution. I'll call this Bernoulli. And let's set a probability. By default, that'll be 0.5. And we'll say if random is less than p, then let's return true. No, sorry, let's return 1. And otherwise, let's return 0. And with our outcomes here, we can say for whatever in range n, and we can change this to a call to Bernoulli with a probability of p. So let's do p by default is 0.5, n is 8. So in this form, this is the same as what just existed with doing choice from 0 or 1, but now we can change p, right? So let me make sure. So outcomes, we need to also change this here. So this is going to be, we should put p 0.5, n of 8, and also update this. So p and n, and let's make sure that still works. Yep, that still works just fine. Okay, so now we can actually, with this code, we could vary the probability per trial, right? Where we could change the probability of success to 0.25 or something like that. So this is a slightly better version of that simulator. So I'll also put this in there. So I'll call this sampling approach with a varying probability. Okay. Hope that's helpful. Hope that's addressing your question about how to simulate a binomial distribution. This is essentially how we teach it in the premium prep. We take a couple other approaches as well, but I think this is the heart of it. Okay, so there's a question here. Complete the function called is either even and less than 9. It takes two numbers as parameters. It returns true if either one of the parameters is even and both of them are less than 9. It will return false if both conditions are not met. Okay, so I'm going to jump back over here to REPL, and I'm going to copy in. I'll copy in what you pasted here, and we'll take a look at this. Okay, so. Okay. Sorry if this is a little bit difficult to read for anybody. Complete the function called is either even and less than 9. All right. So that's the name of our function, right? Def is either even and less than 9. Takes two numbers as parameters, right? So we're going to define two parameters, and when we call this, we'll pass in two numbers as arguments. Okay. So I'll call this num1 and num2. And it returns true if either one of the parameters is even. And both of them are less than 9. Okay, so we can write this a couple different ways. The first thing we can check is one of them even? Is either one even? Okay, so the way we can do that is if num1 mod 2 is 0, right? That's something we can check. Or num2 mod 2 is 0, right? Okay, so that's checking if either one of the parameters is even. Both of them have to be less than 9. Okay? So you can do this a couple different ways. One way is with a nested if, which I'll do here, and then I'll rewrite this to be a little bit different. If num1 is less than 9 and num2 is less than 9, then we can return true. And if these conditions don't return true, well, every other condition is going to return false. So notice I'm not actually doing an else here. I don't need to with this construction, but when I rewrite it, I will do an else. But notice if this first condition evaluates to true and the second one does not, we're going to get down here to this return false either way, and we will not evaluate this as true. So let's try this with a few cases. In fact, we have a few cases here. Let's just grab those. So output is, so 2 and 4, that should be true. 72 and 2 should be false. And then we wait for REPL to run, and hopefully it will. Hopefully I don't have to reload it. Okay, yeah, so that looks like it's working. I'm going to rewrite this slightly. We can make a compound conditional statement here. What I'll do first is I'm going to wrap this first statement in parentheses. And what I'm going to do next is just say and there's no real, you don't have to do this exactly, but I think it's good practice to separate your conditions with parentheses like so. You do need to do this with the or because ands are evaluated before ors. So what I am more inclined to do is switch the order of these, is to put the and first in terms of this compound statement. So that should return true, and otherwise I can use an else in here now. Else we can return false. So there is an error. Where is that? Oh, it's an indentation error. It's right there. And then let's try that again. Oh, if and okay, where is my error here? Oh, I have if twice. There we go. Let's try that. Wait for REPL and see if that runs. Yeah, this is one of the things about REPL. I noticed that there are 2 people connected, and it might be that that's slowing REPL down, but I'm not sure, actually. Sometimes REPL is just slow. So this also works, right? This is arguably a little bit cleaner, but then you get this one really long line, which is fine. You know, no harm done. But this, I believe this should be a working version for that problem. Cool. All right. Let's see. So I've been doing all of this in, essentially in in either REPL or in Google Colab. I also have, VS Code open, and I know some of you are new. You're in the premium prep, starting this round. I think I mentioned this a couple times. I recommend getting a local environment working sooner than later. What I usually say is somewhere around the beginning of week 3 of the premium prep, just so that you're used to it. So you start getting used to it sooner than later. I'm running VS Code locally, of course, and then what I do is I keep a separate terminal, and so let's look at this. So I could put a hello world in here, and if I save it and what is it, shift enter or command enter? It might be, I believe it's shift enter actually. Notice that this is running a Python terminal within VS Code, and that's all in good. This is running Python 3.9, which is fine for me, and this is a sort of standard Python terminal. It's the same terminal that I would get if I just type Python here, right? Can I run something? Okay, no, I can't. I could even exit out of this, okay? And then I am in the same place in this terminal that's embedded in VS Code as I am in my external terminal. I personally don't like using the terminal in VS Code. My main reason for that is that I find it much easier to use Command Tab, or if you're on Linux, Alt Tab or Windows Alt Tab, to switch between my terminal and VS Code. And so what I can do down here is I can just say Python delme.py, and that works for me, right? The other thing I can do offhand is I can type Ipython. Ipython is a really nice, it's a nice place where you can kind of analyze, play around with your code. And I can do run delme.py here, and notice I'm getting the output of that print right there. So what I could do this a little bit differently. I could assign this to a variable, which I'll call string. And so I've got this hello world string, and if I go back over here, I can run delme again. And notice I don't get any output because I'm not actually printing anything. And that makes sense. I'm not printing anything, so of course I'm not printing anything. I'm not getting any output. But what I can do now, there's this variable called string, and I can look at it. I can type string and I get hello world. So let's try a couple other things. We'll do a num1 here, and we'll make this num1 10, and we'll make num2 20, right? And I have to run this again. I have to run delme again in order to have these be in the environment of Ipython. And I can say, well, let's look at num1. That's 10. Let's look at num1 plus num2. Well, it's 30, obviously. Let's look at num2 divided by num1. That's 2, well, 2.0. So what I think is really nice about this is that you can kind of analyze what your variables are, right? You can troubleshoot things pretty easily, and I think that's nice. I think that's a really simple, easy way to look at things using Ipython and VS Code. So that's why I use a separate terminal. You could do the same thing. I mean, technically, you could do that in here, okay, you could type Ipython in your VS Code and run delme.py in here and do all the same stuff. I personally don't like that because for me it takes up real estate from my text editor. This is me personally. I'm not saying it's better or worse, but it takes up real estate and it's harder for me to flip between these screens. I like using just Command Tab to jump around. So, that's how I've been doing this. I find this to be much easier. So kind of along those lines of troubleshooting, there's a thing that I like to do sometimes when I'm troubleshooting that allows me to trace through some of my code. So let me think of a good problem here. Well, why don't we borrow one of these prior problems? Let's borrow. Yeah, let's borrow this one. Let's borrow the sampling process for binomial. And okay, so run this again, and of course we're getting this output of a sample binomial distribution with 8 trials. Easy. Now, if I want to see any of these variables, well, there's only one variable I can really see, and that's D. That's that dictionary that we're walking over, that we're iterating over right here. We can see that clearly right there. So something to notice is that if I type D one more time, that's not changing, right? That's not changing. I'm not actually running delme.py again, so D is staying consistent with these values, which is actually pretty helpful at times. Because if I ran this again, we're going to have different values for D, right? So let me show you a troubleshooting technique that I think can come in handy. There are times where, how about we do this? So in this sample binary function, what if we, for every one of these samples, we print how the dictionary is changing and being updated? So we can print D, and you know, if I do this, well, you know, I'll start here. If I run run delme.py, I'm going to get a lot of stuff out of this. You know, I'm getting this big wall of the dictionary. I can't actually see it as it's changing, you know? So that's not necessarily helpful offhand. But what I can do is I can run input. Some of you have probably seen input already. Input is a way that you can, you know, take input from the console or from the terminal. And that's great. I think using a blank input like this, you know, I'm not saving anything here. I'm not pulling in input from the user and using it or anything like that. All I'm doing is running the input function, and I want to show you what this does for your ability to, you know, look inside what your code is doing. So I just sampled one time, and we had 5 successes. If I hit return, I'm watching my dictionary grow, right? So we had 2 successes, and we're counting, and then we get 4 successes, and 4 successes again. So now 4 is at 2, right? And I can keep doing this. And as I do this, well, I'd have to hit this 1,000 times, right, in order to run through this whole thing. But eventually, I'm going to have a fully populated dictionary from this sample binary. You can take this sort of print input approach, and you know, this isn't the only way to troubleshoot or anything like that, but for these simple tools, like using VS Code in a terminal, this is an effective way that you can troubleshoot. Just print an input. It helps you to see your data structure change with time. And I just exited out of there because, you know, I don't really need to do that right now. Okay. Yeah. Feel free to ask any questions as we're going. If there's something you're hung up on, stuck on, you know, just go ahead and put it in here. And what I'll likely do now that we've got some spaces to work in, right? Here's VS Code, here's Colab, here's Replit. What I'll likely do is just start looking at some simple Python because we are at the beginning of the Premium Prep, and I know there are a couple people in here from Premium Prep. So, you know, I'll probably start going over some basic data types and whatnot if I don't see any questions come in, just for people who are newer to the material. but I'll give a sec for any questions to come in. Okay. All right. So let's think about, yeah, just some basics, some basics. There are these things called data types, and what they are is sort of embedded in the name. They're types of data, right? And that isn't too complex. It's not too hard to figure out. So one of the basic forms of data is called integers, right? And an integer is just a whole number, right? So integers, we can think about them as whole numbers, positive or negative. And one way that we can see this, if I use the type function, right? So I've got this type function, it's going to tell me what the type of -3 is. What is the type of -3? It's from the class int. So notice when we say integer, we're talking about something that in Python it's called int. So it's an int. If I want to store this to a variable, right? I'll call this int variable. Then I can kind of put a degree of separation here, right? So what is the type of int variable? Well, we should see that it is of class int, and we do. So integers are whole numbers. What is the type of 0? Well, turns out 0 is an int. What about -0? What does that even mean? Turns out -0 is an int, which is a funny thing in comp sci in general, but -0 is not something you have to really worry about. I'm just pointing out that there are some kind of anomalous behaviors here and there. Okay, so those are integers. The other numeric type, and I think generally this is what I'm talking about here, is numeric types, right? So numeric types. There are things called floats. And floats, the easiest way to think about these are just decimal numbers. So let's make a float variable. And let's make this 0.0, or why don't we do 0.071, or how about 1.071 or 3.071? And we can just print the type of that float variable, right? So what is that? Class float. We can see that this is of class float. So the type function is going to tell you the the data type of a specific variable. Now there are other numeric types, but the only one I'm going to really point out here is Boolean. So we've got this Boolean. Boolean is only true or false. Okay. So let's call this bool var, and we'll set it to true, and we can just look at this very simply. So bool var, oops, I'm printing this float still, so of course this is of class Boolean, which Python calls a bool. Okay. Now why do we have Booleans? Well, we have Booleans in general so that we can make decisions. We can ask, is this thing happening? Is this thing true? If it is true, then do this. If it's not true, if it's false, then do this other thing, right? And so Booleans come in very, very handy. These are all numeric types. And one thing that we might look at is, well, what happens when we add int var, which is 0? What happens when we add int var with bool var, which is true? What is 0 plus true? Turns out that that's 1, okay? What happens when we add float var plus bool var, right? So this should be 3.071 plus true. Turns out that's 4.071. So when we think about true, we can think about this as being numerically equivalent to 1. And that can come in handy. There are a number of times where that comes in handy. We'll see that a little bit in the premium prep when we write certain functions where, you know, we have an argument that is a Boolean. But we'll see that when we get there. But I just want to point that out, that numerically true is 1. Well, numerically, if true is 1, what is, you know, what would false be? And we can just look at this. If I put in false, float var plus false is going to equal, it's just going to equal float var, right? 3.071. So that's nice. That's, we can think about false as being 0 and true as being 1. So that can be handy. There are other types. So we've got a few other types, but the one that I'm going to point you to is string, actually, which is not a numeric type. It is what we call a scalar type, but let's not worry too much about that at the moment. So we have this thing called a string. And a string is kind of easy to understand. Strings are just sequences of characters that, yeah, like we can just type stuff, right? So this is a string. And if I print the type of string, we're going to see that it's of class str, class string, str. So one nice thing about these classes, let's take a look at these. Let's look at the type of this integer, class int. It turns out that this int right here, it's a class, which means also that we can, in this case, we can use it to create or construct an integer. So I'll call this cast int. I'm going to take a number that is not an integer, okay? Like 0. No, let's not do 0. Let's do 7.054. And let's print this, what happens when we cast this to an integer. Turns into 7. Okay? Now, what is that doing? It's taking 7.054 and it's discarding the 0.054. It's effectively turning that into an integer. And how do we turn it into an integer? We just, you know, put this number into the int function, right? We cast it to an integer. That's called casting. It's like you take it and you put it in a mold, right? And it makes it into something else. So we can do this with all of these, but you know, what I should show you first is what happens when we try to cast a string to an integer. So let's try to cast this string to an integer. We get an error. And you want to start reading errors sooner than later, right? So what does this say? On line 10, that's important, right? The error is happening on line 10. In this bit of code, we get what's called a value error, invalid literal for int with base 10, and then it's like, hey, y'all. So this is a bit cryptic, right? Invalid literal for int. The thing that we are passing in here is not valid for the int function, okay? It's saying with base 10 because integer here is assuming base 10, which is just our normal number system, 0 through 9. Okay, so we can see that we can't cast a string here and have it work. I think that's really the takeaway. Can we, however, cast a Boolean? Can we cast true to an integer? Turns out we can. So true, if we cast it to an integer, becomes 1. False, if we cast it to an integer, becomes 0, which shouldn't be too surprising given our ability to add and or perform numeric operations with trues and falses as if they're 1s and 0s. Okay, so that's the case for integers. We can do the same thing for floats, right? So we can take a float value, and I'll just do this very simply. I'll say, let's cast a float. Let's cast to float the number 72. Now, if we cast this to float, what does that turn out to be? Let me just, there we go. It becomes 72.0. Okay. What is the difference here between 72.0 and 72? Like, what is really the difference? If I look to see if these two numbers are equal, it has to be double equals. If I'm going to check to see if these two numbers are equal to each other, according to Python, what do we get? Turns out that we get true, because effectively 72 and 72.0, according to Python, is that's the same number, or it's the same enough. It's similar enough that we're going to say that that's true, and that's convenient for a lot of numeric operations that we might perform. But if I change this to 72.01, what do I get? Turns out that we get false, right? I don't think that should be too surprising. Also, if I leave this as an integer, what do we get? 72, is that equal to 72.0? Turns out that that still is, of course. That still is. All right, so we can cast integers to floats. We can cast floats to integers. We cannot cast strings, right? We cannot make a dog float. We get an error, could not convert string to float, dog. It's a slightly friendlier error than we got for int, right? Invalid literal. But here we're saying you can't convert a string to a float. It's telling us very directly what the error is and where it is on line 17. So errors are your friends. Sometimes you want to try to make your code error in a way that tells you what's going on. It's not always obvious, so just pointing that out. So here I'm going to show something that might be kind of interesting. Okay, so bool, if we want to see the class name for Booleans, it's just this word bool, which if this ever runs, we'll see. Just waiting on REPL. Well, while REPL is trying to decide whether or not it wants to run, there we go, class bool. This is our function, bool. We can cast things to Booleans. So we can cast, let's cast 874.9. Is that true or false, right? How do we think about that? Is 874.9 true or false? Turns out that anything that is not 0 or empty is going to be true. Okay, so I could put bool of -34. That's going to be true. I could put print bool of dog. Turns out the dogs are true. We can see that. But so those are all true. Those will all evaluate to true when cast to bool. What will evaluate to false? 0 will evaluate to false. 0.0. An empty string. And an empty string just looks like that. It's just 2 quotes. These should all evaluate to false, and they do. There are other things that might evaluate to false. I haven't shown this, but this is an empty list. What does that do? Turns out that an empty list will be false as well. What happens when we do is the int function true or false? Turns out it's false. Why is that? Well, this might be fascinating, a little fascinating. If I just look at what the int function gives us, it actually gives us a 0 by default if I don't run it, if I don't pass anything into it. So I could, initialize 0, this 0 variable, using the int function if I want it to be 0. So that's all well and good. I think we can think about this in terms of casting. We can turn things into other things, and I think that's a pretty reasonable thing to do in various situations. The same is going to apply to strings, okay? I think this is pretty intuitive. If we want to take a float and turn it into a string, like 3.7 or 6712, when I print this, we may not be able to notice anything here, but it turns out that is a string, okay? Turns out that is a string, and when we see it in the terminal, when we see it in the console here, we can't tell the difference between this, but it turns out this is a string. If I really want to know that it's a string, I might look at the type. And another way that I could clearly see that this is a string is I might try to perform a mathematical operation with it. So if I take this as a string and I'm like, well, let's add 3.6712 to 43, see what we get. We actually get an error because we can only concatenate a string to a string. Concatenate, what does that mean? So if we wanted to add 43 and 3.6712 to get 46.6712, this would have to be a number, right? 3.6712 would have to be a number. We can do this. That is something, it's no problem to do. It's 46.6712, not surprisingly. However, there's another operation that we can perform with this plus sign. This is an operator that means addition, but it also means concatenation. Okay, concatenation. And what we can do is we can take two strings and kind of glue them together. We can concatenate them together. And we can see here that we get this output, 3.6712 dogs. Or cats, or people, or cars, or whatever, right? This is just some output that we're getting. So we have about 4 minutes, and one of the things that, especially for people who are early in Python, there's something that I think is very helpful to know about strings. And that is this concept of the f string. Okay, so there's something called an f string. F strings are, profoundly helpful. And I'm going to give you just sort of a rudimentary idea around this. So let's say we have num1, which is 27, num2, which is 34, and we want to make an output string that says num1 plus num2 equals, and then, num1 plus num2. So we could do this a couple different ways. We could say the string of num1 plus the string of num2 equals, and I have to put plus signs in between all of these, okay, for concatenation purposes. So I'm concatenating a long, not very fun to write string here, equals, and then I can do the string of num1 plus num2. And I think that should work, if I got everything right. but it's very easy to make mistakes when doing this kind of thing. Let's see what we get. Okay, 27 plus 34 equals 61. So I wrote that without an error, which is a little bit surprising. If I want to do this in a much friendlier way, I can do what's called an f-string now. F-string just means that you put an F in front of your quotes, okay? And this allows you to do what's called interpolation. It allows you to interpolate into a string, okay? Interpolation is just, you have some character that marks, you're going to take something from outside, in this case num1. I'm going to say num1 plus num2. I'm putting these in curly braces, and that equals num1 plus num2. If I print this, I don't know about you, I think this is much more readable. It's much easier to write as well. You don't have all these weird pluses, and then here's a string of a plus, and all this casting that allows this to happen, and you get the same result. Okay, 27 plus 34 is 61. This is, you know, if you've been watching this whole time, I've been using f-strings today. I use these all the time for making nice console output. It's just friendly. So the sooner you understand f-strings, the better. You'll see them throughout our materials. Yeah, and just helpful to know, helpful to get what these are doing, why they're doing what they're doing. And also just notice you can perform mathematical operations within the string, within the construction of this string, which is, you know, in and of itself, that is really helpful. Cool. So I'm going to wrap up there. You know, this is just for those of you who are just getting started in Python, who are new in the Premium Prep course. I'm going to attempt to generally have study hall. You know, I most often teach study halls on Wednesdays. Sometimes Clark and I switch off for Fridays and whatnot. But I'm going to do my best to, you know, when I'm not answering questions, I'm going to look at what we're covering currently in the Premium Prep, so that we can focus in on that for those of you who are who might want a little bit of supplemental lecture, or who have questions about where we're at that moment. And, you know, I'm always happy to explore concepts, Python or statistical concepts at any point. Just go ahead and ask. That's me for today. We'll have study hall on Friday, same time. That's 3 p.m. Pacific, 4 p.m. Mountain, 5 p.m. Eastern, 6 p.m. No, sorry, 5 p.m. Central, 6 p.m. Eastern. And yeah, feel free to bring your questions, and always feel free to reach out to us on Slack or in the DS Basic Prep or Premium Prep rooms with questions there as well. All right, take care, everybody. Thanks so much for watching, and I will see you all very soon.